How you doing there? So I was going to do a quick video over transformation rules again, and I'm not going to hit every single one of them. I really want to focus on the reflections and the stretch compressions, but know that there are multiple transformations. I mean, universally, they're kind of the same: shift up, down, left, right, reflection, stretch, compress. Finding a chart like this, I highly recommend it. You can find one online, anywhere on the internet. Pretty much are kind of all over the place now. But just having it, I mean, the reason why is because one thing I'll say is just knowing the notation and what it should do helps a whole lot when you're actually trying to apply the transformation. So if it doesn't look like it's supposed to, and you know that you had a reflection across, it's supposed to be reflection over the X, but it somehow ended up on the other side of the Y, something went wrong. At least you have that general knowledge. But I'm going to show you kind of just the general vertical stretch compression, horizontal of a square root function. It looks something like this. And the one thing I highly recommend, again, on this one is draw yourself a table. That way you kind of get the idea as to what you're trying to do. Okay, similar to that. And so when it comes to stretching vertically, the one thing you have to know is that what it's going to do, it's going to take your Y values and it's going to pull them away from the X, this direction right here. So your Y values are being shifted, are being stretched vertically this direction here, okay? Which means that we're affecting the Y value in this case here, okay? So let's just say we had a vertical stretch of 3. So let's just say we had a 3 f of x, okay? We're going to apply a vertical stretch of 3. Since I'm vertically stretching on the Y this way, what I'm actually doing is I'm taking my Y values and I'm actually multiplying them by 3, okay? So that I can stretch it vertically this direction. So when I do that, well, obviously 0 doesn't move, but like my new coordinate here actually becomes 1, 3, and this becomes 4, 6, okay? So that's what a vertical stretch would look like. You're taking it and you're pulling your Y values this direction like this, okay? A vertical compression does something very similar, but instead of stretching it away from your x-axis, you're actually bringing them closer to your x-axis this way, okay? And again, I'm going to kind of just show you one real quick. Let me erase this real quick. Let's just say I wanted to do a 1/2 f of x. And I forgot my f. And again, what I'm actually doing is I'm taking all of my Y values and I'm multiplying them by 1/2. And so when I do this, again, 0, 0 doesn't really move, but this becomes half and this becomes 1. So now my vertical compression looks something like that. And it's not a straight line. It's supposed to be curved, but okay. So that's what a vertical stretch compression actually does. It takes your Y values and it pulls them away from the x-axis this direction, or it brings them closer to your x-axis this way, okay? This is your parent function. This is a vertical stretch. This is a vertical compression, okay? I'm going to erase this time with my eraser because my hands are getting kind of messy. Okay. Well, what about horizontal? Well, horizontal does something very similar. Okay, it looks similar to a vertical compression or stretch, but it's not the exact same. Okay, so just be aware of that. So let's just say I wanted to horizontally stretch by 2. Okay, so again, remember that horizontally we're looking at reciprocal value. So I'm going to be stretching it by 2. The value I'm looking at is 1/2 horizontally. Okay, and again, what I'm going to do in this case though is, if I'm going to be stretching it horizontally, I'm pulling my x values now away from the y-axis, this particular direction, okay? So that means that instead of worrying about my y's, now I'm taking my x and I'm saying, okay, I'm taking all of those times 2. And when I do that, this still stays 0, 0. This becomes 2, 1. And this becomes 8. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, right here. So it looks like it's literally stretching it this way, kind of like a rubber band almost. Okay, you're pulling your x values away from the y-axis this direction. Okay, and that's a horizontal stretch. It looks similar to a compression, but again, notice your y values aren't changing, just the x values. Okay, so it's not vertical compression; it's a horizontal stretch. Similar on the horizontal compression, and again, remember that you're looking at it in terms of the reciprocal value. So if it's a 2x, we're looking at a horizontal compression of 1/2. And so we're taking our x values, and again, we're multiplying by 1/2, such that if this is 1, 1, now my point is half 1, and then this becomes 2, 2, so that my graph looks something like this. Okay, and again, it looks like a vertical stretch, but it really isn't, because your y's are not being affected in this case. Only your x's are being brought closer to your y-axis. So it was at 1, but now it's at half. Here it was at 2 to 1 to half. So everything's being brought in this direction. Okay, and that's essentially what a vertical stretch compression actually do. Okay, and I know that the confusion always is which one is which. Just remember, on a horizontal, you're looking at a change every single time. So it's not going to be the exact value. So this is showing you 1/2. We're really saying it's a stretch of 2 versus this is a 2, but what we're really saying is a compression of 1/2. Okay.